All right. Welcome, everyone. My name is Gus Melendez. I'm the Salesforce Practice Director.
And I'm Christian. I'm a senior Salesforce developer.
And we are from Soliant Consulting. We're a firm that specializes in custom development on the Salesforce platform. We're very much into doing a lot of integration work, working to integrate systems and creating solutions with Lightning. And today we're going to be talking about custom metadata types being used to create flexible APIs.
But before we get started, you've probably seen this before, so make your purchasing decisions based on what's currently available.
All right, so just to walk through our agenda here, first we're going to just talk about custom metadata types, just in case you haven't used them before. And then we're going to talk about the concept of using custom metadata types to do some integration mapping. And then we're going to look at how we can use custom metadata types to sort of read and write in a dynamic REST API, and then we'll talk about some next steps. This session is for those of you who are intermediate developers. You've got experience writing Apex. You have experience working with REST APIs and with JSON. You've developed a custom REST API at some point or are very eager to do so. But more importantly, you're looking to make your integrations be much more configurable. So the first thing is just custom metadata types. If you haven't used them, they're really great. They are a customizable and deployable application metadata in Salesforce, and it's like a Salesforce object. You can, it's got fields that you can create. It can be queried. You can add validation rules, and they're really a great replacement for list custom settings. So if you've used list custom settings in the past to use it for configuring how your Apex code operates, this is going to be a fantastic replacement for that type of feature. So I mentioned it. They kind of build like custom objects. It's a very familiar interface. You have the ability to add fields to them, so things like checkboxes or date fields, text, percent, phone, all that good stuff. But I particularly am very interested in one of these, which is the metadata relationship field, which allows you to map to entity definition, field definitions, as well as relationships to other metadata types. These two entity field definitions, just if you haven't sort of encountered them before, the entity and field definitions, they allow you to create almost like a lookup to an object or field definition. So it's not that it's pointing to a record itself, right? You're not pointing to a data record, but it's actually the field and object definition. So you're able to interrogate, right, settings or data associated with those objects. One thing to note, and you'll see it as we work through the demo, is that there are some objects that are not going to show up in the entity definition fields, as well as the field definitions. So, for example, you're going to be able to select the opportunity object, but not opportunity contact roles. Similarly, there's you can access compound fields like the billing address. If, for example, you had accounts and you were using a field definition based off of the account, but you're not going to be able to access the billing city. So in our code and some of the utilities that we've written, we actually work around that by, in the approach that we use, creating a text field to store the developer name of an object or field that is unavailable through those pick lists. So a little bit about custom metadata and those entity and field definitions as to how they get stored. You'll see here on the right, I actually created a custom metadata called data map. And I added an entity definition, and I also added a field definition field that is controlled by the object field. So I called them object and field, which sounds redundant. But you'll see that it's when you create records, metadata records, it stores standard objects and standards fields. You'll get the developer name, the standard developer name. But when you are referencing custom fields or custom objects, you'll see that it actually stores the durable ID. So as we go through this implementation, make sure that you are sort of traversing those definition fields and getting the actual qualified API name instead of just the field itself, because sometimes it'll be either a standard developer name or it'll be a custom durable ID. All right, so we were thinking about like what is a good approach or a good example to show you guys how we use custom metadata at Soliant to map integrations dynamically. And we thought, well, of course, let's take this session in particular and let's describe it. And so, let's say that we needed to develop in our Salesforce org a custom Apex REST API where an external system, maybe it's the Dreamforce Salesforce org, needs to send us data. And so the JSON payload that it sends to our REST API might contain some of the keys like the name of the session or the start time, the end time, the level, or maybe the room ID. All of these keys, we can think about mapping them to some type of Salesforce object and field, right? So let's say session is a custom object in our Salesforce org, and we've got a variety of fields that map to those JSON keys. Well, we can visualize a table of maps, and that table of maps can actually be recreated using custom metadata. So, and I'm actually, yeah, go back. One, yep. I'll just point out real quickly on here. So, for example, in this particular org, we ended up creating a custom metadata called data map, and already instantiated quite a few sort of mappings. So we had the object called session. We had fields like an abstract mapped to the abstract key. And so our JSON object can now be mapped to Salesforce data just using the very simple approach of custom metadata. So if we have that available, we've built out this sort of custom metadata type configuration, then we could think through a logical process of how to insert data into Salesforce by using those custom metadata types. So the first thing we would do is that when we receive that post, right, your API gets called, you're going to query the custom metadata types, and you're going to build a map of JSON keys to Salesforce fields or vice versa, depending which direction you're going. And then you're going to take the payload that was sent to us, so that session JSON payload, and we're going to parse it. You're going to use an untyped parse. And then you're going to iterate through those fields in that map, and you're going to put the values of that JSON payload for each one of those keys into the corresponding generic S-object fields. And then you're going to insert the record. So as you can see, it's a very simple, straightforward approach. You write very little code, and you hard code nothing, right? Everything is dynamically sort of attached to or put into the right fields just by referencing the custom metadata types. If you wanted to read data instead, let's say that we wanted to actually create a dynamic endpoint that returns back a JSON structure to the client without us having to hard code that JSON structure, then we can do sort of a reverse process. We can use the custom metadata type that we created, and we can query them. We can create a set of Salesforce fields from it. We can create a dynamic SQL query from it. And then we can build up a JSON object with all of those keys mapped from that custom metadata, and then return that back to our client. And so again, in that case, we've actually developed a fully dynamic method for us to be able to return data back to the client without hard coding any of those fields. So Christian is going to switch over, and just in general, what we'd like to do is use Postman in this particular case to emulate some of these techniques.
Yes, so we're going to use Postman as a way to simulate an external system sending data to Salesforce. As you can see, we have it set up to post to our custom Apex REST dynamic API that we've developed. And we're going to be sending the JSON payload that represents our session details. If we switch to Salesforce, you'll see that we've already defined all of the different mappings between the session object fields and the keys inside of the JSON payload. So when we send this, you'll see that a record gets created in Salesforce. And you can see that all of the details, all the fields that we've mapped actually make it through into the record. If you look at the code here, you'll see that this is our dynamic API. And one of the first things that we do is we grab the payload, and then we query for the mappings. And one thing to note is that we're getting the qualified API name for the object and the field We then iterate over those and create a map of the JSON keys to Salesforce fields. We deserialize the data into a map of string objects. And then iterate over those mappings, we're essentially rebuilding the JSON payload as a standard Salesforce object by just grabbing the data from the untyped map and just putting them into the S object. And we just follow up with inserting. And here we just return the session ID as the response. But let's say someone added a capacity parameter to the payload. And normally you would need a developer to go in, edit the code, update the test cases, the deployment, and that ends up taking a lot of time, even though it's a fairly simple operation. But with this, it's as simple as just creating a new configuration. So here we're going to just create a new custom metadata type to represent the capacity mapping. And again, you just select the session object, the capacity field on that object, and the JSON key for the capacity. So if you save this and resend our request, you'll see that there's a new session record in here, which has the capacity mapped. And a few things to know that is you need some kind of safeguards. So in here, I added a simple check to make sure that you have a specific JSON key inside of the payload before you try to grab it, so you don't get an exception. But I guess we'll talk more about other considerations.
Yeah, so ultimately, there's like Christian was alluding to, we glossed over in this particular example over some not so minor details that need to be addressed. So it's an exciting approach. I think it definitely makes an API much more robust and allows you to really grow it dynamically across time. But we have to implement some safeguards. So Christian mentioned just the missing keys, right? Being able to handle missing keys in that JSON payload. But more importantly, and something that we run into quite a bit, is data type issues, right? You're going to have to typecast certain fields, and all of that can be done generally very dynamically. But I'm sure you've all experienced it at some point or another. Data format issues, they can be quite painful, and especially in an implementation like this that is highly dynamic, that is going to become very important. Same thing with FLS or just general exception handling, right? What happens if there's a validation rule that prevents the insertion of the record and all that good stuff? We do have examples of how we handle a lot of these scenarios that's lined on our website, which we'll show at the end. So overall, right, this is a very simple, straightforward approach. I think it's become a really a go-to for us when we're working in implementations like this, really trying to make sure that we're not hard-coding our integrations and that we, one, make it available and open for administrators and non-developers to be able to configure their APIs. But also, it reduces the amount of code that we write and makes it less prone to breaking. Certain things that I think, when we talk about custom metadata types and how they can help in this particular realm, that have me excited is that custom metadata types continue to grow, and we hear lots of great things are coming down the pipeline. And I think, if they introduce things like lookups and metadata records and stuff like that, I think that's going to allow us as developers to implement much more complex mapping structures, right? So we showed the example of just sort of a single level JSON object. You've got all the keys right there. But if you've played with JSON, you've obviously used some type of array or nested objects within that JSON payload. And we want to be able to map those. And I think those types of features will allow us to do so. So with that, are there any questions?
So the problem with using objects is that that data is not saved. You have to redeploy between environments. But with custom metadata, you can just do that as a part of a chain set. So it's much easier in terms of deployments.
Apart from the data being migrated, is there any other
Well, I think in general, some of the benefits are that you are able to establish a very strict configuration of your integration, and so across time, certainly, it can be very narrow for your integration partner. So if you're working with someone, another developer, another system, it allows you to really specify exactly what you get, rather than, for example, telling them, okay, you need to deal with the REST API, like the standard Salesforce REST API.
And
a
also,
little bit narrow.
One of the best features is the entity relationships, because you can actually look through, get a lot of attributes through that lookup, so you can figure out what the data types are. So inside of your code, you can just look through the mapping, figure out what the data type is, and do the appropriate castings. Exactly. Yeah. If we were to use a custom object, then you'd have to define all of that schema again, even though it's already available.
I'm going to need to step down, yeah. Oh, he was asking about some of the benefits of using this versus, for example, just using the standard REST API. Yeah.
Can you generate this even more so that you have to actually have conceptual see the code instead? You get to see any object and everything.
Mm-hmm.
So it's like one generating code that does
Yeah.
most of the stacking.
Yeah, so actually, in a lot of the question here was, could you genericize it even more? Because in this particular case, we instantiate a session record. Completely agree, and actually, a lot of our implementations, we do that. We recently wrapped up a project where it's completely genericized, and we actually are able to map to pretty much any object that we configure it to. But for the purpose of this demo, we sort of slimmed it down.
Yeah, if your external system actually contains the Salesforce ID, you can dynamically grab the object type and instantiate a dummy record. But there's other ways to just configure what the response type should be that it should map to. So.
Yeah. Can you instantiate an S object, just generically?
Yeah, so there's like the type class, and using the type class, you can instantiate objects dynamically. So you can use a string to represent which type you want to get. And once you have the type object, you can create a new instance of it. And then use just the generic S-object methods for getting and setting properties.
Yep. All right. We have one question all the way, but yeah.
What kind of performance overhead have you found?
Performance overhead?
Yeah.
I mean, we're not dealing.
It's a lot of cover limits.
Not really. One of the biggest things is just querying for the mappings initially, and other than that is just looping through them a couple of times. So there isn't really much performance overhead.
Yeah. Yeah, we've I think used it very well with even multiple mappings simultaneously without any performance, or noticeable performance hits. Yeah. Right.
Demonstrated that it's flexible when you're adding a new property to the JSON object. What if you added like a new array or something? Would you be able to handle that without modifying the code?
Right. So that is the question was, what if you needed to add sort of an array, for example, and would we need to modify the code? So right now with custom metadata types, the way that they're currently implemented, we haven't been able to explore sort of nested objects or arrays, for example, within the JSON payloads themselves. So we currently, most of our integrations ignore that type of stuff. So you have to use sort of the first level keys on your JSON object. But we're hoping that the Salesforce releases additional functionality that would enable us to be able to map more complex structures, including arrays of objects.
Yeah, and there's ways to actually do deserialization differently, so you can actually check whether it deserializes into an array or an object, and just, depending on what the response is, do a different set of processing. So if it deserializes just in an object, you can always throw it into an array and then have a generic function that just works on arrays.
You say you cannot, the data cannot be deleted or removed. So you mean schema or data? The metadata cannot be deleted.
That the metadata cannot be deleted.
Yeah, I saw one slide saying it cannot be deleted from production, so it cannot access.
It modify the schema of it.
So schema cannot be modified?
Not in production, no. For that custom metadata type, right?
So once
It must be deployed, yes.
you cannot change it to put right?
Not the data itself, the schema of the custom metadata types. So the fields, for example.
So once out is out.
Yes. That one I'm not responsible for.
Yes.
I have a question about testing. You mentioned that it's nice to have less of it in the code, so you have to write fewer unit tests. I find that I develop in-house, so I'm often putting business logic into my tests, whether it's needed or not.
Right.
Have you guys found that you're still ending up often writing the tests just to help make sure things are happening, or are you writing more generic APIs so it doesn't matter because
Right.
the API?
It really depends. I think whether you write, and the question was whether you write unit tests that have business logic in them, or you're just writing unit tests to cover specifically the operation of the dynamic mapping. And I think it really depends. We've had situations where, because we want to prevent regressions, we write something that does handle the business logic. But oftentimes for what we have right now, a lot of them are just generic. So it tests the actual operations of the puts and any typecasting and stuff like that. All right. Oh, I don't know if we're good on time or not for one more question. OK, yeah.
Normally, we will be writing custom REST API.
Yep.
We need to do some business logic within that. So when we are directly storing this to metadata type, where the logic will be getting operated, this is like you are adding an extra object there, and the operations will be then by fetching those records again and passing them. How that will be if you have any business logic or the
Right. So I mean, it really depends. You could, you could think of and the question was around business logic within your custom Apex REST API, and I would say that it really is going to depend, right? I don't think we've end up implementing such generic APIs that they're used for all integrations. They're always going to have some type of business logic in it. This approach just minimizes how much you have to hard code, essentially, in terms of data mapping. That's about it. So, yeah. All right. Thank you, everyone.